Okay guys, this is my intro lesson for section 5.4, but it goes all the way to the end here. So I wanted to make this very clear. This is an important lesson to help you throughout the rest of our time. First I'm going to start with quadrantal angles. So you'll see I have my sine graph, my cosine graph. Heck, I have a tangent graph down here. We're going to talk about that too. But this is to help you with quadrantals, which are any multiple of 90 degrees. In this case, we're used to graphing with radians. So I'm made my graphs with radians. But what I want you to use this for is we're going to be evaluating functions. And if they give me something like, what is the sine of 0? I don't have to use my calculator. I don't even have to memorize it, but eventually it just gets burned into your skull. But I look at my graph and I go, oh, the sine of 0 is 0. If somebody said, what is the sine of, let's say, negative 90 degrees? I could say, wait a minute, negative 90 degrees, that's the same as negative pi over 2. I look at my graph. I say, oh, the answer is negative 1. We know that sine graphs will go infinitely big. I could keep this graph going, but what you're going to find is usually they will partition off the x-axis and either have us work from 0 to 2 pi or negative 2 pi to 0 or something like that. So whenever you are given a question that has to do with a quadrantal angle, sine of negative 3 pi halves, just quickly sketch the graph if you have to and say, oh, I can tell you the answer right away. That's what the graphs are used for, to help us evaluate stuff really quickly like that. And once again, they might ask us for radian. They might ask us for degree in our near future. And we just have to remember, oh, sine of 270, I can convert that. That's 3 pi halves. My answer is, once again, negative 1 there. So, similarly, let's just go through just a couple quick ones. What is the cosine of 0? Well, I don't know. Well, if I sketch the graph out real quick, I would know that it's 1. Whether it's 0 radians or 0 degrees, I would still get a 1 for an answer. So similarly, if they gave me something like, what is the cosine of 180 degrees? All I have to do is be able to sketch that graph and say, oh, that's the same as cosine of pi. The answer would be negative 1. So as you can see, if I gave you something like this, all you need to know is what that graph is telling you. And you can give me the answer for any quadrantal quickly. Like I said, after a while it just burns into your memory and you go, oh, cosine of 0 is 1. I know it. Cosine of 0 degrees is 1. I know it. So anyway, let's take a look at tangent, because tangent is this guy with asymptotes. And the reason why I wanted to mention tangent is it's a little bit different. If somebody says, what is the tangent of 0 degrees or 0 radians, let's just say it's radians, I would say, oh, the answer is 0 because it crosses right there at the origin. But tangent has asymptotes. So if somebody says, what is the tangent of pi over 2, I would say, that's undefined. I don't have an answer for that thing. So you'll see tangent, if somebody said, what is the tangent of 180 degrees? I look at my graph and I say 180, that's the same as pi, so I can, oh, that's also 0. And remember, the period for tangent is different than sine and cosine. Tangent, we find the asymptotes, and the distance between them is its period. But once again, what I'm trying to say is, if I write down a quadrantal angle, and I say, what is the tangent of, let's say, negative pi, you should be able to go, oh, based on my sketch, I can quickly give you the answer. Now, once again, this is infinite. This tangent graph will repeat this pattern over and over and over again positively. It'll repeat this pattern over and over again negatively. But here's what I wanted to give you the heads up. Usually they're going to ask us for our answers between negative 2 pi and 0, or 0 and 2 pi. Now, think about this. We had a lot of questions at the very beginning where they had something like, what is the sine of 720 degrees? Oh, well, 720, that's just 2 revolutions around the circle. Or, let's go back and look at our sine graph. That would mean if I extended this graph out more, I could hit my location at 4 pi and say, oh, well, that's just the same as this. That's just 0. So, whenever something is quadrantal, we should think we're going to find our answers by remembering what the sketch of the function looks like. So, that being said, let's talk about the things that are not quadrantal. And we have 3 major guys. Here they are. The multiples of 30. Now, these are called pi over 6 angles. So what I call this is drawing the bow tie. If I want to draw a 30-degree angle, okay, I want to draw a 30-degree angle, I would get this guy right here. Now, the thing is, that is also known as a pi over 6th angle. I also know that if I wanted to, I could draw a 150-degree angle. That would end up in quadrant 2 with a 30-degree reference angle, if you get my drift. What I'm saying is, things that result in a 30-degree reference angle will form what I call the bow tie. So I'm trying to draw this as pretty as I can. And you guys hopefully know what a bow tie looks like. A bow tie looks like this. Ooh, that one's kind of crooked. But what I'm trying to get at is I get 4 different right triangles that I can use. This first angle inside here, I'm going to label it pi sixths. Now, pi sixths is the same as 30 degrees, so opposite that would be a 1. That would make my other angle a 60, so I'd call this thing rad 3, and then up here is a 2. So if somebody wants to ask me, anything about a pi over 6th multiple, aka 30 degrees, I have this reference triangle. But I also have this one. Over here, this big angle I drew earlier would be called a 5 pi 6ths angle, which would once again result in my reference angle right here being a pi 6th. But since I'm in quadrant 2, I have to be careful. That would still make this a 1, that would make this a 2, but this guy would be a negative rad 3 now. But I keep moving. If I wanted to, I could draw a 7 pi 6th angle, which would result in this little angle in here being a pi over 6th. Opposite that would be a 1, but I'm on the negative side of the x, so I get a negative 1. Here I get a 2. What I'm trying to say is, if you draw this picture out, ting, ting, I'm just going to label it all. I can use this to quickly find the answer for a pi 6th angle, whether they want sine, cosine, tangent, whatever they want. I could use this for a pi 6th. I could use this for a 5 pi 6th angle. That would put me in quadrant 2. I could use this for a 7 pi 6th angle. That would put me in quadrant 3. And then what's the next one? The next one would have to be, I didn't give myself enough room, 11 pi 6th. That would be in quadrant 4. So I can sketch these angles every single time I have to answer a question about them, or I can think of it as the bow tie. I wanted to leave myself a little room to do a couple examples. So let's suppose they do something like this. I'm going to just jump on this one. What if they said, what is the sine of 11 pi 6th? Well, the first thing I say is, that's not a quadrantal angle, so I don't look at the graph up here, that's not quadrantal. I look at the multiples of pi sixth. And I say that would put me right here. When I go around, bam. That's my reference angle I'm going to use now. And I want the sign, so I would say, oh, negative 1/2, opposite over hypotenuse. Let's go back, get a black pen. I'm going to do something. What if they said something like, what is the tangent of a pi over sixth angle? Well, that would just put me in the first quadrant, and then I'd say, oh, tangent, that would just be opposite over adjacent, but then I'd clean that thing up, multiply top and bottom by rad 3, make it pretty. Remember, when they want us to evaluate this stuff, they always say exact values. They don't say decimals, etc. So exact values, they turn out to be rads or fractions or 0, 1, negative 1. Sometimes we get an undefined. But if I use this bow tie, I can quickly answer a lot of questions. And I say, hey, what's the cosine of 5 pi 6? You know what, I'm going to go get a green color. And I'd say, hey, this is a 5 pi 6th angle. That makes this my theta. And then I go, hey, cosine of that would just be negative rad 3 over 2. So what I'm trying to show you is a strategy. If you draw this bow tie out and you label all the sides, you label all these guys. Ooh, look, highlighter. I'm kind of making it big, though. I don't know how to use the highlighter that well. Anyway, you can label all this stuff and have it as a reference for you to answer any questions quickly. Let's continue because I don't want to make this lesson too long. This is just a strategy to help you on your upcoming stuff. So here we go. Let's talk about pi over 4 angles. Those are 45s. We have special right triangles for all this. So I'm going to draw this one out much quicker. Watch. I know that if I had a 45-degree angle, those would look good. I'm going to do it over here too. Okay. Then I connect it. Oop, got a little crooked. And then I connect it. I make 4 separate little right triangles. And they all have a 45-degree or pi 4th feel to them. So the first angle in quadrant 1 would be 5 pi 4ths. What's opposite the 45? There's a 1, there's a 1, there's a rad 2. Then my next angle over here, this reference angle here, that would be based on this guy right here, which would be a 3 pi 4ths angle. So just like I did with the problems up above, I'm going to find out that, well, that would make this reference angle in here, this theta, 45. So I'd have a 1, I'd have a 1, I'd have a rad 2. Let me get rid of, see if I can make that a little prettier. I got, okay, you got my thing, there. And then that would make that a negative 1. Over here I'd have a negative 1, I'd have a rad 2. Let's fill in all these blanks here. This would be a negative 1, that'd be a regular 1, okay? Once again, I'm going to try that highlighter. Dink, dink. Ooh, if I just tap it, it's pretty good. Then it's not so huge. You learn something new every day. Anyway, this would be my bow tie for my pi over 4 angles. So any multiple like this, so pi 4ths. Now, if I said 2 pi 4ths, I don't have a reference triangle for that. 2 pi 4ths reduces to pi over 2. That makes it quadrantal. You see, I'm skipping over some of them. So what are the guys that we get out of this bow tie? Pi over 4, 3 pi 4ths, 5 pi 4ths, 7 pi 4ths. This puts me in quadrant 1, this puts me in quadrant 2, this puts me in quadrant 3, this guy's in quadrant 4. And once again, I can use this If they happen to ask me any question like, hey, what is the secant of 7 pi fourths? And I say to myself, wait a minute, my brain works in terms of cosine, so if I found the cosine, I'd say it's 1 over rad 2, but then I could say, I'm going to flip that over, so my answer is rad 2. The bow tie that I'm showing you for a pi over 4 angle means anything multiple of 45, and I haven't done this yet, but what if they gave me something like a negative 5 pi fourths angle? I could still use the same bow tie, but I'd be starting over here and I'd be rotating clockwise. That would put me there. That is a horrible angle look, but where do I end up? I end up coterminal with this guy right here. So whether they give me positive or negative angle measurements, I can use this bow tie to quickly answer questions. Hey, I'm going to get rid of that last little mark I made. What if they ask me to do something like, what is the cotangent of negative 5 pi fourths? I draw my reference angle, just like I did here, negative 5 pi fourths. That means I'm going to use this guy as my reference, and I would say cotangent. I don't think in terms of cotangent, I think in terms of tangent, so I do opposite over adjacent, I get negative 1. But then I take the reciprocal of negative 1, and I go, hey, the reciprocal is also negative 1. There's my answer then. So this strategy is going to be very helpful when we go into lesson 2, lesson 3, heck, the rest of our lessons. You would see if it was a regular classroom and we were still in there. I have 3 separate whiteboards in front. You guys know what the classroom looks like. What I usually do is I draw this reference, this guy on the left board. I draw this guy on the middle board. And then I'm going to do this last dude here, pi over 3 multiples of 60. I draw this on the far right board. Well, stage right, I guess. Well, from where you're facing usually. And I say, this is a really good thing to have on one sheet of paper in front of you whenever you have to evaluate stuff. And you start getting stuff just stuck in your head, and eventually you just stop looking at the page. Some people say you can memorize all these answers. I say, why don't you just embrace that you have a very great diagram you can use, and eventually it will get stuck in your head anyway. So if I were to draw a 60-degree multiple bow tie, it's going to look a little bit more like this. Come on, there you go. And then I'm going to go this way. Oh boy, that was kind of crappy. But, okay. And this looks like a TIE fighter from Star Wars, kind of. It does. Don't say it doesn't. But what do these all have in common? These are going to be multiples of 60 or pi thirds angles. And opposite the pi third would be rad 3. This would be a 1. This would be a 2. Opposite this guy, this would be a rad 3. This would be a 1, but it'd be a negative 1. That would be a 2. What I'm trying to show you is this quick strategy to label everything so that when you need to use it, oh, what the heck did I do there? When you need to evaluate something, you got it real quick. Let's do this trick again. And you can fill in all the signs, whether they're positive or negative, and it makes it so much quicker. Let's just jump on one of these like, hey, I want to know what the tangent of pi over 3 is. I already have my triangles. I have my bow tie. I'm looking at it, and I say, oh, well, that's just rad 3 over 1. I'm just going to call that thing rad 3. What if they want to know the sine of 2 pi thirds? And I say, sine of 2 pi thirds, Well, where would that put me? Let's get a different color. Here, come on. Well, 1 pi thirds, 2 pi thirds, right? Because you got to know, this would be 3 pi thirds to get it, to this location. So that's a 2 pi thirds angle. Hey, there's my little reference angle they want me to use, and I need the sine of that, so I would just say that's rad 3 over 2. I don't need to grab a calculator. I don't have to draw a new reference triangle for every single question. This is just a strategy you might want to employ to make it easy on yourself. Now, let me ask you, since I got this one right here, if they had asked me for the sine of a negative 4 pi thirds angle, that would be going clockwise. That would be 3 pi thirds, because halfway around is pi radians. And then I'd go a little bit, would these two guys be the exact same answer? Yes, they would. They would be coterminal. They both have the same exact reference triangle when you get there. I hope that this little piece of information I've given you is very helpful, because we have a lot of stuff coming our way in the next 3 lessons where they're going to be doing a lot of this stuff to us. And it sure is helpful to have those 3 bow ties. Also, these quadrantal concepts in our head to make it easier to find the answer quickly. So let's just finish up here. What are the multiples here? You'd have pi over 3, 2 pi over 3, that puts you in quadrant 2, 4 pi over 3, that puts you in quadrant 3. So we got pi over 3, 2 pi thirds, 4 pi thirds, 5 pi thirds. Why didn't I write 6 pi thirds? Well, because that's 2 pi and that's quadrantal. I have a different strategy for that. So what I'm trying to say to you guys is use these bow ties to your advantage in the next couple sections. All right, I hope that you jot this stuff down, because these are my multiples here. And remember, they could be positive, they could be negative. These guys, they could be positive, they could be negative. Same here. These guys could be positive, could be negative. But it's a way to speed things up and make it easier on you to answer the questions in the next section. I hope you watch this video, because it's really good info. Okay, and don't forget, this is where I started. All right, bye.